Okay, so 5.3, we're going to be talking about polynomial functions. So let's go ahead and do this. Polynomial expressions in standard form, right, are when we write the polynomial in decreasing order of degrees. Okay, in descending order of degrees. And remember, a polynomial function basically is one where the variables have exponents that are integers, right? 0 or above. Okay. The coefficient of the term with the largest degree is called the leading coefficient. The degree of the polynomial is basically the greatest degree of its terms. So, take a look here. We have this polynomial expression. We want the degree. That's the highest exponent, which is 6. And the leading coefficient is the coefficient of that term, which is a 5. All right? So let's talk a little bit about function notation. So here we have f of x, and we want to find f of 3b minus 1. That means every x has to be replaced by 3b minus 1. So this is going to be negative 2, 3b minus 1 squared, minus 3, 3b minus 1, plus 4. This is negative 2, 9b squared, minus 6b plus 1. Distribute the negative 3, so negative 9b plus 3, plus 4. Now, negative 18b squared plus 12b minus 2 minus 9b plus 7. Altogether, I have 18b squared plus 3b plus 5. Okay. The skill here isn't, oh, sorry, this is a negative. Negative 18. The skill here isn't anything new. It's just maybe, you know, a little bit more complex. Okay? All right, let's do this next one. Here I have 2f of 3x and then minus 5 f of x plus 1. So this is like a whole bunch of things. So first, we're going to do this part. Okay? So f of 3x, now we're going to put 3x into the function, is going to be negative 2, 3x squared, minus 3 times 3x plus 4. So that's going to be, oops, ooh, what did I make where did I make a mistake here? I put the exponent in the parenthesis. It's got to be like this. Good. Okay, good catch. So this is negative 2, 9x squared, minus 9x plus 4. This is negative 18, x squared, minus 9x plus 4. Okay, but what the question calls for is 2 times f of 3x. 2 times f of 3x is 2 times all of this. So this is negative 36x squared minus 18x plus 8. Okay. Okay? So now, that's the first part. Now next, here I have f of x plus 1. So why don't we do f of x plus 1? No, I'm just multiplying by 2. I'm not squaring.
No.
Huh?
In the negative 2 and then in the parentheses 3x.
Here?
Yeah.
It's, yeah, so negative 2 times 9x squared. And then it'll be negative 18 times x squared. Right? Okay, I know you don't believe me, but it'll come to you. Okay, f of x plus 1. So let's see, that's negative 2. X plus 1 squared minus 3x plus 1 plus 4. Okay, so negative 2. Okay, here we need to square this. So it's going to be x squared plus 2x plus 1 minus 3x minus 3 plus 4. This is negative 2x squared minus 4x minus 2 minus 3x plus 1. So, can we simplify that further? Yeah, negative 2x squared minus 7x minus 1. Okay, now let's put it all together into this. So I have 2f of 3x minus 5 times f of x plus 1. 2f of 3x, I just found it. It's here. Okay? Minus 5 times, this is f of x plus 1. Okay? So, this is negative 36x squared minus 18x plus 8 plus 10x, squared, right? Plus 35x plus 5. So this is negative 26x squared. And let's see what we have. Negative 18 plus 35 is plus 17x plus 8 plus 5 is plus 13, and that's our final answer. Okay? Not for too long. Okay? All right. Okay. So, again, nothing new here, but just kind of, taken up a level. Okay, let's talk about graphs of functions. We've got a lot of ground to cover today. Graphs of polynomial functions. So, the shape of the graph of a polynomial function shows the number of times the graph may intercept the x-axis, right? And this is the same as the degree of the polynomial. So for example, if you have a degree of 0, right? So like what is an example of an equation for that line? Let's say y equals 3. Well, how do we even get y equals 3? It's like y equals 3 times x to the 0, right? So this is a degree of 0, and it crosses the x-axis how many times? 0. If you have a degree of 1, it'll cross the x-axis 1 time. That's a linear equation. A degree of 2 is a quadratic, right? 2 times it can cross the equation. A degree of 3 is a cubic function, so it can cross the graph 3 times. 4 crosses the graph 4 times. It's called a quartic function. And then a quintic function is allowed to cross the graph up to 5 times, right? A little bit of Latin and Greek here for you, okay? Okay, let's talk about end behavior. Okay, let's talk about end behavior. End behavior is basically how the function behaves at the very ends. Most of the time, the only numbers that we're focused on is like the origin and maybe like a couple of numbers to the left of the origin and a couple of numbers to the right of the origin. The most we'll have is like f of 10, right? But let's get away from that. Let's get away from near the origin to over here when x is like 100, 1,000, 1,000,000, 1,000,000,000, 1,000,000,000,000, right? Or when x is negative 1,000,000,000,000 on that side. How the function looks, where it goes vertically at those very ends, that's what end behavior is. So, if the degree, the highest exponent, is even, we have two situations. In both cases, at the very ends, both of them will be facing the same direction. So it'll either both go up or both will go down, okay? So if the leading coefficient is positive, both of these will go up. If the leading coefficient is negative, both of these will go down. How does that sound? Hang on, let me. So for example, look at this. You have x squared. It's positive x squared. Both ends go up. If it's negative x to the fourth, right, even exponent but negative, both ends will go down. So the way we write the end behavior is this. Here, when I go over this way, x approaches positive infinity. When I go over this way, x approaches negative infinity. So now, when I go over this way, x is approaching positive infinity, right? What is happening to the graph vertically? Where is it going? Up to positive infinity. So I say, as x approaches positive infinity, f of x approaches positive infinity. But then as x approaches negative infinity, f of x also goes up. It approaches positive infinity. All right? Okay. So when the degree is odd, both ends don't face the same direction. They will face opposite directions. So when you have a positive coefficient, to the right, as you go to positive infinity, where will the graph go? Positive infinity. And if you go to negative infinity, it goes down to negative infinity. All right? Okay. Here, if it's a negative coefficient, it's opposite. Okay? So if you go to the positives, it goes down. If you go to the negatives, it goes up. Okay, why don't we do some examples here? For each graph, describe the end behavior, and we're going to see whether it's even or odd degree and the number. Okay, so for end behavior, here's what you're going to do. As x approaches negative infinity, f of x approaches blank. As x approaches positive infinity, f of x approaches... Okay, I'll show you guys how to do infinities. So basically it's a sideways 8. So you're going to go, look up here. Right? You're just going to do this. Please don't do two circles next to each other because that doesn't look right. Okay? Okay, so look. As x approaches positive infinity, I'm sorry, let's do the negative first. As x approaches negative infinity, where is y going? Down to negative infinity. As x approaches positive infinity, where is y going? Down to negative infinity. This is the end behavior. So when I ask about end behavior, this is what I'm talking about. All right? Now, since these are the same, this is even degree. How many zeros are there? 2 zeros. Okay, here, end behavior. Again, as x approaches negative infinity, f of x approaches something. As x approaches positive infinity, f of x approaches something. Now, when we are writing positive infinity, it's not necessary to include the plus. So, as x approaches negative infinity, where is the y going? Up to positive infinity. And as x is going to positive infinity, where's y going? Down to negative infinity. Are these two the same? They're different, so this is odd degree. Okay, since these are different, this is odd degree. How many zeros? 1, 2, 3, 4. 4 or 5? Count. 5 zeros. So 5 real zeros.
We have to write real.
Yeah.
Why is it real?
Huh? Well, we should have written real for the first one too. Okay.
Is it always real?
Well, if it's an x-intercept, it's a real zero. Okay. So, all right. As x approaches negative infinity, f of x approaches blank. As x approaches positive infinity, f of x approaches blank. So the minute you're told end behavior, you just write this whole thing down. Okay. As x approaches negative infinity, where does f of x go? Positive infinity. Good. And then on the other side, negative infinity. Odd or even? Odd degree. Odd degree because these two are different, right? And how many real zeros? Three real zeros.
Circles next to each other, but it's not.
You guys will get the hang of it. I'll know, trust me.
Really difficult.
I know. So, as x approaches negative infinity, well, imagine writing, as x approach, imagine if you had to write infinity and 8 together. Okay, so as x approaches negative infinity, where does f of x go? Down to negative infinity, and on the other side? Okay, so odd or even? Even degree. How many real zeros? Okay, now, it's really easy if you're given the graph. What if you're not given the graph and you don't have a calculator available? Well, you have to look at the leading term.
How come now it's like not the same?
Well, it's not written in standard form, right? So if we put it in standard form, it would be descending. I do it on purpose so you know to look for the highest degree and not just the first one. Okay, so the leading term is x to the 4. Is that odd or even degree? Even. Does that mean? Okay, so they're going to be the same. So take a look. So again, we want end behavior. So we're going to do as x approaches negative infinity, f of x approaches this. As x approaches positive infinity, f of x approaches this. So now look. It's even, so we know they're going to be both the same. Now, you look here. Positive means both will be positive. Okay? So positive infinity, positive infinity.
Just because the 4 is positive?
No, because the 3 is positive. Okay. So here, that's the leading term. So, all right. So as x approaches negative infinity, f of x approaches something. As x approaches positive infinity, f of x also approaches something. Okay, so.
Yeah, it would be negative.
Huh?
It would be negative.
Okay, so this is odd, which means they're gonna be different. So now we have to decide which one is gonna be negative and which one is gonna be positive. Okay, so here's how I do it. You can either memorize that if there is negative in front, it goes down on the positive side and so on. Or, we always need to have a backup to memorizing. Here's how you can do it. It's negative x cubed, right? As x goes to positive infinity, on the positive side, pick your favorite positive number. What is it? 1. Positive 1. Put 1 for x. Will the result be negative or positive? Negative. So this will be negative infinity. On the negative side, let's pick our favorite negative number, negative 1. Put negative 1 in here. It'll be negative, negative, positive infinity.
Wait. Oh, we already done.
No, I can't repeat it. Listen.
Would it always just be
Just pick a positive number, put it in here, the result will be positive. Pick a negative number, put it in here, the result will be positive. Okay,
Wait, would it always be opposite?
take out your
If it's positive,
calculators.
it's negative, if it's negative, it's positive.
Yeah. No.
When you like do it for me, and you
No, if it's negative, it'll be like that. If it's positive, then on the positive, it'll be positive, and then the negative, it'll be negative.
But if it's negative,
If it's negative, yes, it's switched. Okay. Take out your calculators. Okay, so take a look. Okay. A toaster oven manufacturing company has determined that their profit function, P of X, is this. This should say is, that their profit function is P of X, where X is the number of toaster ovens sold annually. Graph the profit function with your graphing calculator. So go ahead and graph. So we're gonna put in the graph negative 0.001 x cubed plus 0.2 x squared. Okay. Okay, graph it please, quickly. Enter. Okay, you don't see anything. Okay, purposely, right? You don't see anything. That's why the first question here says, determine a proper graphing window or a viewing window. So let's look up here for a minute, please. In this particular problem, the horizontal axis, this is the independent variable. What quantity does it stand for? Number of toaster ovens sold. What variable is that? X. What does the dependent variable vertical axis stand for? Not F. What's the name of the function? What's the name of the function? P of X. What does it stand for? In this problem, what does it stand for? Profit. This is the number of ovens sold. This is the profit. You need that in order to determine a proper graphing window. So if we're selling, right, the ovens or whatever, right? So let's see. So let's go to tab, I'm sorry, not tab. Let's go to menu, window zoom number 4, window settings. Okay, so here's what I'm gonna do. I'm gonna go maybe from negative 100 to 250. Okay, now listen to me. This is the number of ovens sold. And I remember you can't sell negative numbers of ovens, but we're going to do this in order for us to get the entire function. And then the rest is the profit, right? So let's go, I don't know, maybe negative 2,000 to 2,000. Okay? So graph, look at that. That is a very good window. Now, listen to me. Okay, guys. Okay, so here we're going to write, when I ask you for the reasonable window, X min, negative 100, X max, 100. I'm sorry, we did 250. Y min, negative 2,000, Y max, 2,000. Okay, next, approximate all the zeros of the function. Again, I understand some of these are in the negatives and they don't really apply for our toaster oven problem, but nonetheless, mathematically, there are zeros of the function. So remember how to find zeros. We go here, I'll do the first one, and then you guys can go ahead and do the second one. So I have X equals negative 43.870. We're going to go to 3 decimal places. And go ahead and find the other 2. Okay, if when you find your zeros, you don't have enough decimal places, what do? Hover on top and press the plus sign. Okay, so go ahead and find the other 2, please. Okay, these are the zeros, right? These are the other two zeros. Now the question says, what must be the range of the, what must be, there should be a B here. What must be the range of toaster ovens sold in order for the company to have a profit? So look at this graph. If this is profit, first of all, now we have to be on the positive side of the x-axis. Profit is this graph, right? The x-axis is zero profit. Anything above that, you have positive profit. So how many toaster ovens should be sold in order to get profit? Something between the second zero, like 26.17, and this one. Now, we're not going to sell 26.17 toaster ovens, but we have to break that mark in order to start making a profit. So the first one that makes you a profit is how many toasters? 20 what? 27. So between 27 and 218 toasters. Because you can't sell 26 point, like you have to break the 26 mark in order to make a profit, right? And then the first whole toaster after that is
Why
27.
don't we just go down to 26?
Because if you sell 26, it's under. You're not going to make a profit for 20.
Like you'll be in that.
You'll 26 okay. All right. So let's move on to the next one. A clothing manufacturer's profitability can be modeled by this equation. Okay? Where X is the number of items sold in thousands. Okay? And P of X is the company's profit in thousands of dollars. Okay? All right. So let's go ahead and graph this one now. So first, before I do anything else, here's what I'm going to do. I'm going to do doc B because I need to reset my windows, right? Okay. So let's go ahead and graph this one. Negative X to the 4.
Are we not missing like cube? Like it's 4 3 2
No, it doesn't have to be. So negative X to the 4 plus 40x squared minus 144. Okay, look at that. So a good profit window. Okay, so it looks like, negative 10 to 10 is okay. A good, reasonable window. But I don't see anything in the Y's. So why don't we, okay, so let's go to window zoom, window settings. Okay, and you know what? I'm not going to tell you the answer right off the bat. Why don't we go from like negative 1,000 to 1,000? Okay, that's a bit much, right? That's a bit much because we can't really see all the details. Why don't we go menu, for window settings, why don't we go from like negative 400 to 400? Look at how much better this is, right? Because you don't have that empty space and you can really see some fine details. So a good window then is going to be, is going to be X min and X max, negative 10 to 10, Y min and Y max, negative 400 to 400. All right? Between what two values should the company sell in order to be profitable? Okay, now this is a different situation because here, right, X is the number of items sold in thousands. So here, let's find the zeros right here. Menu, analyze graph, 0. This one is 2. And what's the other 0? 6. So between 2,000 and 6,000 items because these are all in the thousands. Okay, so between 2,000 and 6,000 items. Okay. All right, so that's that.